talked about variables which can store one value. The value can be an integer, a decimal value, a char, and many more. But what if you want to store multiple of them? Let's say there are 10 kids in your grade 5 class and you need to find out the tallest kid in class. The way you work on a piece of paper is that you store all 10 numbers and find the largest of them. If you're to do the similar thing in a program, then you can create 10 variables. For example, A1, A2, all the way up to A10. And then in each of them, you can store each of the kids' heights. The other possibility is to store all 10 of these in one organized list. This becomes a data structure. A data structure lets you organize different data based on your need to store and retrieve information. This is one fundamental topic of computer science, and we will only talk about a few basic ones, as they can get very, very complicated. Let's look at a couple of real-world examples. First, organizing toys. This can be done in a data structure. So, you group all of your video games or video game toys into one list. And in the other one, you group all of your little cars. And in the other one, you group all of your RC cars and helicopters and all that stuff. Or books in a library. Each of the books are put in a list, and that is the whole library. Instead of having lots and lots of variables to store each and every book, you can organize them all into one list. Then you have clothes. In your closet, you have racks of clothes. And you can group these. So one rack can be t-shirts, the other one can be pants, the other one can be jackets, and so on. These are data structures, and they're very, very useful in programming, and they help you do many, many things. Let's look at a few more examples of data structures. We already discussed list of heights of kids in class. We can list the different zip codes of a city, the different states in a country, and the items on a menu of the restaurant. Most of the examples, just like the restaurant one, are about storing n number of the same data. But there are other kinds of data structures where data types can be different. For example, the list of books in a library. Let's define a book first. A book has many properties. The title, the author, the subject, the ISBN number. And there's a way to organize a bunch of different types of data together. That is a class. We'll briefly touch on that in this course. So let's look at some different examples of data structures. So there's arrays, which we will be covering, lists, tables, or multidimensional arrays. These three we will cover in the course. These are more complex, and we will not be covering them in the course. These include linked lists, hash tables, trees, and graphs. A data structure is a way to organize information. But what are the basic operations you would want to do with them? As we talked earlier, with about variables, the basic operations are storing a value and retrieving that stored value. In computer science terminology, this is called read and write. Along the similar lines are the basic operations you expect from a data structure. You have to be able to add an element to it or write to the data structure, remove an element for it. You have to be able to find the element, and you have to be able to traverse the data structure. What traversing means is that you iterate through each element in the data structure so that you can find whatever you want. Mind that each element is each thing that you're storing inside. For example, if you have a list of books, you have book 1, and then book 2, and book 3, and book 4, and all of this is a list. Then the 0th element, remember in coding it's 0, 1, 2, 3 instead of 1, 2, 3, 4. The 0th element, this is called an element, right? In computer science terminology, this is called the 0th element. For example, when you want to figure out the 10 tallest kids in your grade, after you've listed them all down, you can traverse through it and check which one is the tallest. An array is a kind of data structure. They can group things together, and in the memory they're stored right next to each other. So let's take a little look of what happens in the memory. Let's say this little box is your memory, and in the array, let's say each of these are all integers. Then, since there's 5 here, there would be 5 boxes here. And as you can see, they are indexed. So, this is the first little box, second box, third box, fourth box. But wait, in coding, it does not start from 1. It starts from 0. So it's 0, 1, 2, 3, 4. So this way, they're indexed and stored right next to each other in the memory as one single unit. So, an array is a little bit like a bookshelf. You can have one book here, a second book here, third book here, fourth book here, and a fifth book. Except, as I said earlier, they're not 1, 2, 3, 4, 5, and so on. It's 0, 1, 2, 3, 4, and so on. So, this is called indexing, where in this list you can choose a certain bit of the list. For example, if you want the 0th element, then you can ask for the 0th element, or the second element, or the first element, whichever one you really want. You can also have a list of booleans, chars, floats, and all of the other things. But remember, each of these have to have the same type. So, this is how you define it. Over here, you have to define what each of the elements are going to be. In this case, it's an int. Then you have these 2 square brackets to denote that it is, in fact, a list. Then you have the name. And then you have all of the values. And they are within these curly brackets. So in this case, there is 1, 2, 3, and 4 stored in it. And remember, if you want the 0th element, then 1 is the 0th element, right? And then the first element is actually 2, and the second element is actually 3, and so on. Alright, so now let's see how to find out the length of the list. The length of my list is 4, because there are 4 elements in it. To find that out, we write mylist.length, and that's it. That will give you an integer, which is how large the list is. Now let's look how to loop or traverse through arrays. This is a little bit of a shortcut, as you can also use indexing in a for loop, but this is a much easier and simple way. So, first you define your int I, and then you put a colon and whatever list you have. And I will change, and you'll be able to traverse through each of these elements. So, in this case, it will print 1, 2, 3, and 4. Because on the first iteration of this, I will be 1. And then on the next iteration, it'll move to the second one, and it'll be 2. Then it'll be 3. Then it'll be 4. So, this is a good way to traverse your elements. For example, when we're trying to figure out who's the tallest kid in our class, we could traverse it and keep on checking who was the tallest, right? So this is very useful when you're dealing with arrays. This is a string, and it is another type of variable. So you might ask, why didn't I introduce you to this before? Well, a string is kind of like an array, as it is, you can think of it as a list of chars or characters. For example, you can store your first name, your last name, your parents' name, your name of your favorite sports team. I have introduced this in the data structures section because they are very, very similar to arrays. Just like this, you can also index strings. Let's say you want the 0th element, which in programming is the first one of the string. Then in this case, it will output J. So these are very useful for storing different names of cities, this, that, lots and lots of things. But let's look at some more things that you can do with strings. First is string concatenation. Let's say I have a string named LName, that stands for last name, and in it is stored Johnson. So if you want to print out Jack space Johnson, then inside of the brackets you could do name, which contains Jack, plus LName. The problem with this is that it would print Jack and then Johnson, but there wouldn't be any space because none of them have spaces. So instead of this, you can write plus and a string that doesn't have anything, just a space, and then another plus, so that there's a space between them. So, like I said earlier, strings are kind of like arrays. So, how do you access each of the characters inside of the string? Well, you can use char at, and in the at, the A is capitalized. Then in the brackets, you write whichever index. So, if you do 0, it would do J. Note that you have to do whatever the string name is, which in this case is name, dot char at. And this will find the character that is in the index that you put in. Practicing array indexing. Pause it here, try out this exercise, and then after a few seconds I will show you the answer. Here is the answer to. As you can see, to find out the last one in the list, I used L dot length. This was a little bit of a bonus question, but then I took away 1 from it, and it got to the last element. Now let's take a look at the min and max of array. In this one, find out the min and the max of this array in separate loops. Then print it out. Pause it here and I'll give you the answer after a few seconds. Here is the answer. For find min, all we're doing is a simple loop traversing all of the values, and we're checking if each of the values is less than our current min. Then if it is, we make that into our new min. Then we print it out. Similar thing here with max, except obviously we're doing the opposite thing. Now let's run it to see what's the min and max. The min is -1, that's right, and the max is 10, that's right. We'll be practicing strings and operations on them. First, we have to do string concatenation. So you have the string hello and the string world, and you have to put them together into hello world. This should come out to be hello space world, and then print this out. And then you have to find out all of the characters in hello world, right? So you have to print each and every one of the characters. Then you have to print the number of a certain character in a string, which in this case is hello world. Pause it here, and after a few seconds I will give you the answer. So, here in string concatenation, we are simply using plus and a string with a space. Here we have all characters as In a string, we are using char at to find a certain character, and here to find the particular character in the string, which is char c, we are using this count and a for loop. Then we are printing it out.